Hello everyone. Today we are going to solve the program smallest subarray with sum greater than x. So it is a difficulty easy question. So given a number x and an array of integers ARR, find the smallest subarray with sum greater than the given value. So if such a subarray do not exist, then return 0 in that case. So we will solve a example, the first sample input only. So coming to the constraints, big O of n and big O of 1. So we will first write down the first sample input so that we can explain. The first sample input is x is equals to 51. So we will also take same x is equals to 51 and ARR is equals to the given values are 1 4 1 4 45 6 0 19. So they are the given values. So the given values are, the first sample input is this. So now we will solve using our logic. So first step, we will take three tracking variables which are sum, track our current sum up to here, and the left variable also starting with 0, the first index, and the result variable to store the least possible length that satisfies the condition which they gave. So the result will be at the max possible value. So let us simply write as infinity. Let us suppose the maximum possible value in the integer. So now we will iterate a loop which is right is equals to 0 to n minus 1, that is 0 to, here n is equals to, we can see 1 2 3 4 5 6, so 6. So the r value will be 0 to 5, so like that. So for every iteration, so let us do here. So for r is equals to 0, the first iteration which r is equals to 0 means we will check, first we will add to the sum. So sum now equals to, what is the value at r is equals to 0? It is 1. So we will add 1 to the sum. So next we will check. Is sum greater than x value? So it is not. So sum value is 1 and x value is 51. So it is not greater than. So do nothing. So next r is equals to 1. So if we add into the sum value will be 5. Again check if sum greater than x. It is again not. Now when r is equals to 2, first we will add the value. So 5 plus 45. One four 45 6 0 19. So the correct only. Now the sum becomes, we know 5 plus 45 is 50. Now again if sum is greater than x. Still it is not greater than. So now r is equals to 3. So we can see now when r is equals to 3, the sum becomes 50 plus 6, which is 56. So now if sum is greater than x, yes, it is greater than, because 56 is greater than 51. So now we need to do some steps. So if it is greater than, then we will continuously do one thing until our current sum will be greater than the x. This is a condition only for the loop. So what do we do? So we will try to remove one character from the left, so that what is the maximum possible value at that particular of point we can get the minimum length. So minimum length. So we know starting we wrote that the minimum length in this question we will be taking as RES. So RES is equals to minimum value of RES comma how to get the current window size or the current array size which we are adding. So we added the values from left to right. So the length will be right minus left. So it is 0 based indexing. So plus 1. So the now min value, the RES value will be, what is the RES? Now R minus left. So R is 3, left is 0. So 3 plus 1, it is 4. So 4 comma infinity. So obviously 4. So RES is equals to 4. So now again, what do we do after we compute the min value? We will remove sum and we will remove sum minus the array of left value. So reducing the window size. So now the sum becomes 56 minus 1. So it is 55. So like that. So we had the sum value as 56. So 56 and minus 1. So it is 55. And the left value is now 1. Because we deleted one index from the window. Now we again check if our sum value is greater than x. So it is obviously again greater than. So again min is equals to the RES. So the RES is equals to minimum value from the current value RES minus R minus L plus 1. So right is 3, L is 1. So 3 minus 1 is 2, 2 plus 1 is 3. So 4 comma 3. So RES is now 3. So again remove left element. So sum minus array of 1. Again 55 was it is there. 55 minus 4. So it is 51. So now left is equals to 2. Now if you check, the sum value is not greater than. So simply R is equals to 3 also iteration is completed. So now the remaining two iterations are R is equals to 4 and 5. So here the space is not sufficient. So let us write here. So now we can see what was the, we will write the values here. Now we will compute the R is equals to 4 and the x value is 51 and array is 1445 45 6019 and the left value is currently at 2 and the sum value is currently as 51. So these are the values we need to make the calculations. So now for r is equals to 4, we all know again we need to add to the sum. So sum is equals to now 51 plus 6, so it is 57. So now if you check if our sum is greater than the x value, so it is greater than, so now again we will process. So now while this condition is holding, we will check that minimum, so it is a RES minimum, not a normal one. RES is a result, so RES is equals to minimum of RES comma right minus left plus 1. So what is the value? RES is, we wrote here, RES is we didn't write here. RES is currently 3, so 3, and right is 4, 4 minus 2, so 2, 2 plus 1 is 3, so 3 comma 3, so the again RES is equals to 3, and from the sum value we will remove the value at L is equals to 2. So what is the value at index 2? It is 45. So 0, 1, 2, 3, 4, 5. So at index 2 it is 45. So after removing, the sum value is 57. So 57 minus 45, the values here, so 2 and 1, so it is 12, and the left value is now 3. So now if you check again, so the sum value is 12, it is not greater than x. So now we will compute the last iteration, which is r is equals to 5. So again add, so sum is equals to 12 plus the last element is 19, so 19, it is 11, so 31, so sum is 31. And if you check if sum is greater than x, so it is not, because sum is 31 and x is 51, so the loop ends here. So at last, what was the RES value at the last checkpoint? You can see it is 3, we computed here. So after all the computations, we know that RES is equals to 3, which is also we can find there. So this is how our logic will be working. So it may look bigger because of the number of iterations. So you can see these are the computations. So what we did, so we take some variables, we run the iterations. So there are two conditions. First we will add in the loop the r value and we check if sum is greater than x. So if it is greater than, we try to minimize the length of the window. So we keep on doing this same process iteratively until we get the RES value, which is a 3. So you can see we got the RES value as 3. So this is how we can do this program. So now let's solve this program with the same logic but using the programming. The logic or the programming code length will be so much less than what you think. So now the first step was we take some variables which are the int sum is equals to 0, initially, and int the left value is equals to 0, and int the res value is also maximum possible value, such that any value will be the minimum value than that. So for int right is equals to 0 and right less than array dot length and right plus plus. So we said first we will add the right value. So sum plus is equals to array of right. So after that we will compare that if sum is greater than x. So we try to minimize the length of the window. So length of the window will store in the res. So res is equals to mat dot min of minimum of from res comma right minus left plus 1. This gives out the window size. So now remove the value, the left value. So array of left and increment the left value. So if you check, if res is equals to maximum value, then this holds as a case where there is no such sub value or also the whole array. Even adding all those values, we didn't get any greater than case, that the sum is greater than the given value threshold x. So that case the res will not be even updated once also. So in that case return, they said to return 0. So we can see here, if subarray does not exist, return 0 in that case. So in any other cases, return the res value only. So I can say the sample test case is not passed. There is a small error. So you can see if sum is greater than x, res is equals to mat dot min of sum left res value, r is equals to 0, r less than array dot length, r plus plus, sum plus is equals to array of I. So there is a small error. Now we will check with our logic. So we said the right value will be starting from the 0 only and goes until the array dot length and r plus plus. So if our sum value is greater than x they already gave, then result is equals to mat dot min of result comma r minus left plus 1. So after that we will remove the array dot left array's left value from the sum and left will be incremented by 1. Now we will compare our code with the actual logic which we wrote. So we will see. So first step we did was to initialize those values, which we already did correctly, and next we will go one by one. So we can also see the second step. So now we will observe. So int we took the n value, the left value, the minimum length value which is the dot max value, and right is equals to 0, right less than array dot length, right plus plus. So if our, now we will be adding the right value and check if, so we did a mistake here. So we said we will do this internal minimizing process until not only once. So it was a while loop. So we wrote here, in this step we did 2 times. If you observe here, this is only possible if you do until, then until is only done using the while loop. So we simply use the if condition there, small mistake. So now we can see the sampled input is passed. Coming to the reader test case also, they are also passed. Now we analyze the time and space complexities. These 3 variables all take big O of 1 only space. This loop takes big O of n. Internally, these loops will not take any time big O of n, not even a log n, because there are only small set of that window size where it is possible. Then it is roughly big O of 1 to maximum possible log n. Then like that, this condition takes big O of 1 of time. So finally, our time will be log n. It is actually not log n, maximum possible value. So actually our time will be n only, or n into log n, and space is big O of 1. So now if you compare, they are matching. So if you think about this, if our code complexity is exceeding the expected one, then the solution will not even be accepted. But it is accepted because the time complexity of the inner loop is not even log n. It is very less, like big O of 1 or a little higher. So that is why it is submitted successfully. So this is the best possible solution for this particular program, and also understandable. So kindly go and practice this program. The program link is in the description. Thank you for watching. Subscribe for more videos.